Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 2, Lesson 4, Parallel and Perpendicular Lines. After this lesson, you'll be able to write equations of parallel lines and perpendicular lines. For the Explore and Reason, we have these three lines. Let's practice using our graphing calculator. So take out your graphing calculator. We're going to plot these equations into our y equals. So you're going to go into y equals, the upper left button, and type in these three equations. And we're going to compare the lines. How are they related to each other? So on our graphing calculator, again, you go to y equals. Make sure your plots are off, so none of the plot 1, plot 2, plot 3 icons at the top are highlighted, so make sure they're unhighlighted. And then you just type in the equations, 3x plus 1, 3x plus 2, 3x plus 3. Then we can hit graph. And we can see those. I did zoom in, so if you want to zoom in, you can hit zoom in number 2, and click on enter wherever you want your cursor to go, and it will zoom in. So you can see I have those three lines. I notice the lines are parallel. They do not intersect. They have three different y-intercepts. One intercept is at 1, the other is at 2, the other is at 3, but they never cross. They are parallel. Example 1, writing an equation of a line that is parallel to a given line. So we are given this equation for this line. It's in slope-intercept form, so we know the slope is 3/4, and we know the y-intercept is at -2. A new point, or a new line, goes through the point 8, 9, and it's going to be parallel. So if lines are parallel, what did you notice from the equations that were parallel? They all had the same slope. M was the same in all of them. So if we have parallel lines, then I know the slope needs to be the same. So the slope is going to still be 3/4, but now it's going to go through another point. So if I know the point, and I know a slope, what form of my linear equations am I going to use? I'm not going to use slope-intercept. I'm going to use point-slope form. Okay, so y minus y1 equals m times x minus x1. I'm going to just substitute the values I know. Y minus the opposite of my y value. My y value is 9, so the opposite of 9 is -9, equals my slope has to stay the same since it's parallel, so it'll still be 3/4. Times x minus my x value, so the opposite of my x value is 8, so it's going to be -8. There's my equation in point-slope form. So after we get our equation here in point-slope form, we're just going to distribute and turn it into slope-intercept form. So 3/4 times x and 3/4 times -8. And then move the 9 over to the other side, and we get our equation of another line that is parallel. It has the same slope, but a different y-intercept. So it is a different line, but it is parallel to the original line that they gave us. So instead of having a y-intercept of -2, now my y-intercept is at +3. Write the equation of the line that passes through each given point that is parallel. So remember, it's going to have the same slope. If it is parallel, has the same slope. Okay, so my slope needs to stay -2/3. I'm going to write point-slope form. Y minus my y value equals my slope times x, and the opposite of my x value is +3. My x value was -3, so when I do subtract -3, I get +3. Okay, then I can distribute my 2/3. I get -2/3 x. The 3's will cancel, so I'll get -2. I will add 5 to both sides to turn it into slope-intercept form. -2/3 x plus 3. So yes, it has a different y-intercept, but the same slope. Okay, look at letter B. My slope is 0, so I need to have the same slope. Y opposite the y value equals my slope is 0 times x opposite my x value. My x value is +1. Opposite of +1 is -1. Okay, distribute. I get y minus 4 equals 0. Add 4 to both sides. Y equals 4. y always equals 4, I will have a horizontal line at 4. How about perpendicular lines? So what are perpendicular lines? Well, they are lines that are 90-degree rotations. So we have this right angle. Lines are perpendicular. When they intersect, they form a right angle, a 90-degree angle. And you can see the relationship between the slope. So for line L, the red line, my slope is b over a. Remember, slope is rise over run. For line P, my slope is a or negative a over b because I have to go down. So I'm comparing these, negative a over b and b over a. These are called negative reciprocals. If I multiply them together, I should get negative 1. So b over a times negative a over b. The a's will cancel. I get negative b over b, which equals negative 1. So negative reciprocals give you a product of negative 1. So opposite and flipped if they're perpendicular. Slopes are opposite sign and reciprocals. Part B, determine whether the lines P and T are perpendicular. So we have to look at the slope of each. Let's look at the slope for T. I have this point here and I have this point here. So my slope is, I go up 3 and over 4. So my slope for T is positive 3 over 4. For the red line, for slope, for line P, I have to go down. Let's see, we're using this again. I go down 4, so that's a negative 4, and I go over 3. So my slope for the red line is negative 4/3. Are those negative reciprocals? Yes, they're opposite sign and reciprocals. So that means they are perpendicular. For the second example, let's calculate the slope for T. So I go up 4 and over 3, so that's a positive 4 over 3 for the blue line. For the red line, again, I have to go down, so I'm going down 5 and over 4, so my slope is negative 5/4. Those are not reciprocals. They do have an opposite sign, but they are not reciprocals, so they are not perpendicular. They're not parallel either, obviously. A line K has a slope of 2. So I know my slope is 2. What would be the slope if the line is perpendicular? So remember, I have to do the opposite sign. So a perpendicular slope would be negative. And then I have to do the reciprocal. What's the reciprocal of 2? Well, the reciprocal is 1/2. So the perpendicular line would have a slope of negative 1/2. Example 3, writing an equation of a line perpendicular to the given line. Okay, so here's our given line. We're looking at the slope. The slope is negative 1/4. So if it's going to be perpendicular, I have to look at the negative reciprocal. So instead of being negative, my new slope should be positive. The reciprocal of 1/4 is 4 over 1. So my new slope should be 4. Okay, I know it goes through 1/7. So I have a slope and I have a point. I'm going to plug this into point slope form. Okay, so again, the opposite of positive 7 is negative 7. There's my slope, substitute 4 for m, and the opposite of positive 1 is negative 1. So then if we want to turn this into slope-intercept form, we just distribute the 4. I'd get 4x minus 4. Then I would add 7 to both sides. I would get y equals 4x plus 3. So there's my slope. That's a negative reciprocal. That's the equation in slope-intercept form of a line that is perpendicular to the original line they gave us. Write the equation of a line that passes through this point, 4, 5, and is perpendicular. So again, identify the slope. The slope is 2, so my perpendicular slope needs to be the negative reciprocal. Now I'm going to plug it into point slope form. Y opposite my y value is positive 5, equals my slope times x opposite my x value, which is positive 4, so I'm going to have negative 4. And then we'll just distribute plus 2, add 5 to both sides. Y equals plus 7. There's my equation for a line that's perpendicular. Again, check the slope. It should be a negative reciprocal. Now we just need to check, are these perpendicular, parallel, or neither, comparing these two equations. One equation is in standard form, one equation is in slope-intercept form. Well, slope-intercept form is easy to identify the slope. It's -3/4. So now I just need to look at the standard form equation and find the slope. So turn it into slope-intercept form. Move the 4x to the opposite side by doing the opposite operation. Again, we can't subtract -4x from a constant, so we just write them side by side. Then divide by the coefficient, divide everything by the coefficient. So that means we divide -4 by 3 and we divide 6 by 3. And then we get this equation in slope-intercept form. Our slope for the standard form equation is -4/3. Are those negative reciprocals? Well, no. They're reciprocals, but they're not opposite signs. So these are neither parallel nor perpendicular. All right, let's check these. Here's part A. The first slope is 2. The second slope is 1/2. Are those negative reciprocals? Nope, they are neither. Okay, for part B, my slope is -5. And my other slope, well, it's in standard form, so we're going to have to rearrange it. So let's turn the standard form equation into slope-intercept form so we can compare the slopes. Move the 25x to the other side. I get 5y equals -25x plus 1. Divide every part by 5. -5x plus 1/5. My slope now is -5. Compare that to the first slope, -5. Well, they're the same, so that means these two lines are parallel. You can also use this symbol for parallel. I use this symbol for perpendicular. You've seen me use that. Application problem. A farmer decides to use part of her land to generate solar energy. She plans on installing rows of solar panels either perpendicular to Meadowway or parallel to North Road. So we're going perpendicular to Meadow or parallel to North Road. Okay, so let's see if I can do this. She's either going to go parallel this way or she's going to try to go perpendicular. So they're not quite the same. I don't know if I can draw perpendicular. They're slightly off. They're not quite the same. So we need to find the slope of each of these lines of North Road and Meadowway. We need to find the slope of those two, and then she's going to have them go through this point. So no matter which direction she goes, they're going to cross through this ordered pair 4, 3. So starting with Meadowway, let's find 2 points. I'm going to zoom in. Let's find 2 points we can use to find the slope. So 2 points that are exact. Well, I have a y-intercept, 0, 2. And then it looks like I can do this point, 5, 2. So from those 2 points, I went, 0, 1. I went up 1 and over 5. So my slope for Meadowway is 1/5. Okay, for North Road, I want to use points that are exactly on a corner. I've got, that looks like 1, 7. And I've got 2, 3. So there's 2 points I can find the slope. I go, I'll just draw it. I go from 7 down to 3, that's -4. And then I go over 1. So my slope for North Road is -4. Using those slopes, we're going to write our equations in point-slope form using the same slope or the same point. Different slopes for each road, but the same ordered pair 4, 3. Now remember, for Meadowway, she's going perpendicular to Meadowway. So Meadowway's slope is 1/5. If we're going perpendicular, the slope is going to be -5. She's going parallel to North Road, so the slope will still say -4. Okay, so keeping that in mind, here's the perpendicular slope for Meadowway, -5. Plug in the point, opposite the y value, opposite the x value. And then parallel to North Road, it should stay the same. The slope should still say -4. Plug in the y value and the x value. So with these two equations, we could distribute and turn them into slope-intercept form, but we don't need to because we're just looking for an equation, we're going to plug in any value for x. So now she knows she can plug in an x value and know where she's supposed to put the y value. So she can plug in any points that will have the same slope. She doesn't need to use slope-intercept form. She just needs to have points and a slope. Suppose the farmer decides to build the second row of panels starting from a location at 9, 4. So now our point is different. The slopes are still going to be the same. Okay, so remember, one slope was -5 and the other slope was -4. So we're going to write those two equations. Y opposite the y value equals my slope times x opposite my x value. Let's practice distributing. Y minus 4 equals -5x plus 45. I'm going to add 4 to both sides. Y equals -5x plus 49. Again, you don't need to do this, but I just want you to practice going from point-slope form to slope-intercept form. Okay, the second equation with a slope of -4. Y minus the y value equals my slope is now -4 times x minus my x value. Again, let's practice distributing, turning it into slope-intercept form. Plus 36, and I will add 4 to both sides. Y equals -4x plus 40. Here's the concept summary for parallel lines and perpendicular lines. Remember, parallel lines, the slope is the same. Perpendicular lines, the slopes are negative reciprocal, opposite signs, and flip the slope.